Today I will talk something about electrophysiology of vision. As we all know, eyes are our window. Advancements in the field of biomedical electronics and in the field of electronics and communication system have changed the perception of eye. It is estimated 150,000 severely disabled persons able to control only the muscles of their eyes without any problem. There are three common visual electrodiagnostic tests: EOG, ERG, and VEP. I will introduce more on EOG. Amy Dubois-Raymond observed that the cornea of the eye is electrically positive relative to the back of the eye. Since this potential was not affected by the presence or absence of light, it was thought of as a resting potential. In fact, it is not constant, but slowly varies and is the basis of the electrooculogram (EOG). Alvin Mark named the electrooculogram in 1951, and Geoffrey Arden in 1962 developed the first clinical application. Here is the anatomy and physiology of the eye. The eye and its major components are shown in Figure 28.1. Light enters the front of the eye at the cornea. Behind the cornea exists a transparent fluid called the aqueous humor. Its main function is to make up for the absence of vasculature in the cornea, the lungs, by providing nutrients and oxygen. The aqueous also is responsible for generating a pressure of 20 to 25, which inflates the eye against the relatively elastic boundaries provided by the sclera and the choroid. This ensures an appropriate geometrical configuration for the formation of clear images by the optical pathway. The line is located behind the aqueous humor, completes the focusing of the light, began at the cornea on the retina. This is a drawing of the major elements of the retinal cellular structure, is shown in Figure 28.2. In this figure, light enters from the top and passes through the neural structure to the photoreceptors, which are the rods and the cones. Just behind the rods and cones is the retinal pigment epithelium. Its major function is to supply the metabolic needs of the photoreceptors. The rods respond to dim light, whereas the cones contribute to vision in bright light and in color. This area is the site of visual excitation. The EOG is the electrical signal produced by the potential difference between the retina and the cornea of the eye. This difference is due to the large presence of the electrically active nerves in the retina compared to the front of the eye. The main application of the EOG is in the measurement of eye movement. In the Figure 28.3 illustrates the measurement of horizontal eye movement by the placement of a pair of electrodes at the outside of the left and right eye. With the eye at rest, the electrodes are effectively at the same potential and no voltage is recorded. The rotation of the eye to the right results in a difference of potential, with the electrodes in the direction of movement, becoming positive relative to the second electrode. The opposite effect results from a rotation to the left. As it can be seen from the above figure, 4 to 5 electrodes are required for the detection of the EEG signals. In the process of detection, the electrodes act as a transducer converting the ion current obtained at the skin to electron current. The derivation of the EEG is achieved placing 2 electrodes on the outer side of the eye to detect horizontal movement, and another pair above and below the eye to detect vertical movement. This is the EEG recording. It requires diode and the skin electrodes near both casings of BE. Ground electrode at the forehead lighted room, and then 3 fixation lines 15 degrees apart. Look left and right with 30 equation at a rate of 15 to 20 rotations per minute. In this figure 3.2, the diagram top figure shows the 3 types of the eye movements, and the bottom figure shows the original EEG waveform. Positive or negative pulses will be generated when the eye is rolling upward or downward. The amplitude of a pulse will be increased with the increment of rolling angle, and the rise of the positive or negative pulse will proportional to the duration of the eyeball rolling process. When the eyes are stationary or when the eyes are looking straight ahead, there is no considerable change in potential, and the amplitude of signal obtained is about 0. This required the baseline, keep lights on for 5 minutes, and then turn off the lights. Record for 15 minutes in dark adaptive state, and then turn on the lights. Record for 15 minutes in light adaptive state, and then recording sampled at 1 minute intervals. At last, response decreases progressively during dark adaptation. In Figure 53, these are 10-second periods of eye movement back and forth between 2 red LED lights placed 30 degrees apart inside the Ganze field. Here is the 2 important components of EEG. Light sensitive means light peak contributed by rods and cones, and then is light insensitive means dark throat, contributed by RPE, photoreceptors inner nuclear layer. The most common use of the EEG nowadays is to confirm Behçet's disease. Behçet's villiform macular dystrophy and variants of this disease are usually identified by the appearance of a retinal lesion resembling an egg yolk early in the disease. The chart figure 54 graphs the change in voltage in the eyes through 15 minutes of dark adaptation and 15 minutes of bright light. The figure 55 shows an abnormal response recorded from a patient with Behçet's disease. Here is my reference. That's all my presentation. Thank you.